I can't tell if it's going or not. Okay. Hello, everybody. It's the astronaut again, and today we're taking a break from mathematics and we're going to science, more specifically chemistry. Today we're talking about electron configurations. Now, I had someone ask me to help explain this to them, and when I started looking around trying to figure out how to do that, I was very confused about some of the things I found. Okay, for example, in one particular book, I found an image like this. Okay, while it explains it, it doesn't explain it properly. Okay, and we'll come back to this image in a little bit, but first, I want to come over to this slide, and this is how I do it. Okay, this is how how I believe it should be done. Okay, electron configurations is really just counting how many spaces there are to each element. If I'm explaining that properly, it helped me to see some examples. So, for example, my first example here is hydrogen. H is just hydrogen. It's right here. I'm going to write the electron configuration, and then I'm going to explain it. Okay, it's actually. Oh, that's not what was supposed to happen. Hold on, I'm sorry about that. That's the electron configuration for hydrogen. Now let me explain. The periodic table can be broken up into 4 different blocks, if you will. Okay? There's the S block, the P block, the D block, and the F block. Now this is the order of them, okay? Right about there. Actually, let me do that in a different color. This is the S block. I'm going to draw this really carefully because it's very specific. Here we go. This is the P block. This is the D block, and everything down here is the. Actually, let me do that over here. That's the F block, of course. Okay. Now, trying to do it the way it is kind of confusing because you got helium over here just kind of not in anything. Okay. In reality, helium needs to go right there in the S block. Okay. It's the second element in the S block. Okay. So now we just count. Okay. If we come back to this one, it's really confusing trying to count. Okay. But it does show the progression nicely. Okay. You've got. Oh. Sorry about that. S. S again. Then you got P. S. P, S, D, P, S, P, and you got a D over here, and so on and so forth. But it does show it nicely, and we're not going to get into F because that's weird, and it does not need to be covered in this video. But if we come back over here, let's do a few more examples. Let's just do helium, okay? What about helium? Okay, since helium, this is hydrogen, okay? It's the first one in the S block, okay? So we're counting it's in the first period, okay? And it's the first element in the block, okay? Let me go ahead and just write the other periods. It's just 1 through 7. I'm just confusing myself. 5, 6, 7. Again, it's just 1 through 7 appropriately. 1, 2, 3, 4, 5, 6, 7, of course, all the way across. But helium is just like hydrogen, okay? It's going to be 1 S, because it's still in the first, it's in the first period, okay? It's in the S block. But it's not the first one. Instead, it's the second one. Okay? So instead of being 1s1, it's going to be 1s and it's written like 1s to the power of 2. Okay, now let's do one that's a little more complicated. How about we try... Oh, screen just flashed. How about we try boron? Okay, boron is right here. It's number 5 on the periodic table. Okay, so what's the electron configuration of boron? Well, let's take a look. It's in the... Oh, whoop. I keep whacking that. It's in the second period, and it's in the P block, okay? Now, the way this is, it's not just 2p1, okay? That'd be too simple, okay? But the way you do it is you take everything you can from here, okay, from the first period, okay, which is going to be, since there's only 2 elements in the first period, it's going to be 1s, if I can do that. I'm trying something new so I can maybe draw a little bit neater. 1s2, space. You don't really need to put anything here. Then you make a space, and then you go to the second period, which is over here and starts with lithium. Okay, so you filled in your first section of orbitals, and I'll get you a definition for that a little bit later. Actually, I think I forgot to write one down. You fill up all of your 1s orbitals, and then you go to the next level, like this one shows. 1s, then you go to 2s, okay, 2s, and then you get to 2p, right? So 1s, we got all those. 2p, or 2s rather. There's 2 more in this s column, so it's going to be another 2s2 in space. And now we've gotten into the p column because we're coming straight across. Because we're not intersecting this D block, we're not going to do anything about that until we get down here by Scandium. Okay, so we don't care about the D or the F right now. In fact, we're not going to mess with the F at all. Just going to keep whacking that. So now, this is the second period. This is the P block, and it's the first element in the P block. Okay? Gosh darn it, I gotta stop whacking that. Okay, it's the first element in the P block, which means the total electron configuration for boron is 1s2, 2s2, 2p1. Okay, and if you wanna get complicated, you could do you could say that boron is it's got the electron configuration of beryllium, and then you put your 2p1. Okay, if you really wanted to get technical and write it, it's like the scientific notation of electron configuration, if you will. Okay, it's noble gas configuration, I believe, but it's not a noble gas. But if you wanted to do that, you could. It doesn't really matter. Personally, I don't like doing it. I like putting the whole thing so I can see if I made an error. And yeah. Now, the cool thing is, which you might have already noticed, is that these exponents up here, change color, these exponents up here, if you did it properly, they should all add up to the atomic number, which if you've taken chemistry, you know is the number of protons and electrons in this specific element. Okay, boron is number 5 on the periodic table. 2 and 2 is 4, plus 1 is 5. Okay, so you know that you did this right because you got it 5. You've come to the right. You've come to the right. Go back. Come to the right orbital and everything. So you now know you've done this right. And if you come back to helium and hydrogen, hydrogen is 1 and helium is 2. Okay? So you know that because this is only 1 down here and is corresponding to 1, you can't really screw that up. This one, it's just number 2. Again, is really kind of difficult to mess it up once you actually know what you're doing. Now let's go something a little even more complicated than boron, okay? K. K is potassium. It's right here, number 19. Okay, let me choose a new color here. A new color, okay? That'll do. Potassium is number 19. So all of these exponents, when we write it out, should need to add up to equal 19. Okay? Let's just write that there, 19. Let's just put that in brackets over here. It's some messy brackets. I'm not very good at drawing on here. Now let's write the electron configuration. So it's going to be the same as boron up until we get to here, okay? Because this is the one that's specific. This is the section right here that is specific to boron. None of the others will ever have this exact same ending electron configuration. None of them will ever have that. Okay? None of them will ever have that. But because we know it's going to be the same as boron up to this point, we can go ahead and just kind of, without having to do anything else, just kind of do 1s2. Come over here, go. Oh my gosh, that did not work. That's too small. Yeah, I'm not very good at this. 2s2 2p. Okay, now we just have to change this. Okay, but remember we're going over here to 19. This is for number 5, so we gotta go 1, 2, 3, 4, 5, 6. And that's the whole p orbital block in this row, in this period. So we can only go up to 6 right here, right now. Okay, now just like we did when we went to boron, we have to go up another period. Okay, to period 3. So we're gonna go 3, and because we're coming from left to right, we're going left to right, we know that we have to start here with potassium. Okay, potassium, there's 1, 2 in this S block in period 3. So 3s, because that's the next section. And there's only 2. There's only ever 2 in the S block. So it's always going to be S2. Always, unless you're choosing one of these, like we're going to. We're getting ahead of ourselves. 2s, okay. Then we come over here to the P block. And since we're not on this P block, we're on the next level of S, we're going to have to put another 3, because it's the third period. P, because it's in the P block. We're going to fill in all of them. Use all these elements to fill this orbital, okay? 1, 2, 3, 4, 5, 6, so 6 goes there. Now, we're just about done, okay? We come to the fourth period here, and potassium's right here on the end, okay? But we're not done. Just like we did with boron in specific, the others were just kind of numbering, but with boron, we put 2p1 because it was the first element in this P block. Just like that, we're going to do the same thing over here with potassium, but with the S block. Alright? So it's going to be 4. We're in the S block. 4th period in the S block. Okay? 4th period in the S block. And it's only the first element in the S block. So we're going to go do 1. And that's the electron configuration for potassium. But just to prove it, okay, 2 and 2 is 4. 6 and 2 is going to be 8. 61 is 7. You add those together, you get 19. Which proves that we did it right. Now, if we go back to the other one over here, this one doesn't so much help you get the correct electron configuration for each element, but instead it shows you how many pieces are up to this orbital. Okay? In 1s1, you've only got 1 orbital. Okay? In 2s, you've got 1 orbital. But actually, no, it doesn't. Because that's wrong, because that would have to be different. Yeah, this one's weird. It just occurred to me that that's not right. 1s1 only has 1 orbital, that's right. 2s2 has 2 orbitals, though. 2p2, if we come over here, we see we got 1, 2, 3 orbitals. Which is right. Oh, what just happened there? I don't know. 3 orbitals, okay. 3s should have more than that, though. It should have 4. It should be constantly going up. So this is just a really, really weird way of trying to show electron configuration, and I'm not entirely sure what it's supposed to mean. If you're having trouble with it, you should ask a teacher, but it shouldn't matter because of this way, and this way is a lot easier. Okay, let's do one more example, if I can get my eraser out. Let's do one more example, just so that we can be sure we've got it. That did not fill in properly. Here we go, this worked. That worked, okay. Now let's go and let's get this, and we've already got a color we don't use yet. So let's choose Scandium, because Scandium is over in the D block, and we haven't talked about the D block at all yet. Okay, so Scandium. Since we can just look at it and know that Scandium is in the D block, but it's also in the fourth period here, we know that it's going to have the same electron configuration as potassium up to the specific part like boron had here. Okay, so we can just go ahead and fill it in, even though I just erased it. It was 1, 1s2, 2s2, 2p6, because that's all the way through here. Now we've got, under the third period, 3s2, 3p6 to fill in this whole third p block orbitals. And then we got 4s, and now here's the specific part for potassium where we would put 1, but instead we need to go past it all the way over to there. So we're just going to fill in both of those. So it's going to be 4s2. And now here's the thing. If you go by the rules of all the other blocks, not all the other blocks, but if you go by the rules of the S and P block like we have been, it would be 4D, that was really bad D, 4D1, right? It would be that way if you went the way we did with the S and the P blocks, but you don't when you have the D orbital. Okay, the D orbital, you actually take whatever period it's on, in this case 4, and subtract it by 1. Okay, 4 minus 1 is 3, of course, so it would be 3D1. Okay, that is the electron configuration for Scandium. I'm just looking up the proper way to write it just to make sure I did it right. Okay, I did do it wrong. I didn't do it wrong, okay? I didn't do it wrong. It's just not in the way it should be yet. We were just going all the way through and doing this. But when you get to the D block, everything needs to be in order of number, okay? For example, here we've got I need a new color. Let's go with this nice purple. Let's go with purple. Purple's good. We got 1. Okay, then we get 2, another 2, 3, another 3, 4, but then we go back to 3. Okay, so that's not the way numbers work. You don't go 1 to 4 and then back to 3. That's not how that works. So instead of putting this here, this needs to be put right here in between the 3p and the 4s. Okay, right there. So instead of looking like this, it would look like it would be 1s2. Actually, let me just erase it. 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, and then we go to the 4s2, because this is a higher number of total orbitals filled, whereas this one's all the way back at 3 because you had to subtract one with the d orbital. I know it doesn't make much sense, but that's how it works. If you have any questions, feel free to ask them, and give me a new topic. I'd love to see what you guys need help with.